Hey folks, Professor Gray here, ready to talk to you more about hypothesis testing with one sample. In a previous video, we talked about the overall process and identifying the null and alternative hypotheses. Now we'll talk about the use of tails in a hypothesis test as well as significance level. To test the probability of the sample data under the assumption that the null hypothesis is true, we need to know what part of the distribution is involved. Well, that's revealed in the alternative hypothesis. A test may be right-tailed, left-tailed, or two-tailed, both right and left. In a left-tailed hypothesis test, the alternative hypothesis involves values less than the sample data. So the sign used in H sub 1 would be a less than. In that test, if our probability of the sample data falls within the tail, then we reject the null hypothesis because it is sufficiently rare. If that probability does not fall in the left tail, then we fail to reject the null hypothesis because it's not rare enough for us to make that statement. On a right-tailed hypothesis test is the mirror of that. It's used when the alternative hypothesis involves values greater than the sample data. In that case, we're using the right tail, and if the probability of the sample data occurring under the null hypothesis is within the tail, the right tail, then we reject the null. Otherwise, we fail to reject the null. The sign used in H sub 1 is greater than in that case. On a two-tailed test, that's used when the alternative hypothesis involves values not equal to the sample data. So if the probability of our sample data falls within either tail, left or right, we reject the null hypothesis. Otherwise, we fail to reject it. And the sign used in H sub 1, the alternative, will be a not equals to. So back to our running example we're using for these videos. Number 2 says to identify the tails or tail used in this test. Well, for number 2, if I look at my hypothesis statements, H sub 1 uses a not equal to. So this is a two-tailed test. Both left and right. If I were to sketch that, it would look something like this. When I look at the distribution of data or probabilities, I'll be watching for my sample data to fall in either tail. That leads us to significance level. In order to see if the sample data is rare, and use the rare event rule, we need the significance level. The significance level is the total area in the tail or tails of the distribution used for the hypothesis test. It's denoted alpha. I'll tell you a little bit more about that a little later on. We compare the significance level to the probability of the sample data under the assumption of the null to determine if the sample data is rare or not. So the significance level in a way is kind of like a line in the sand. Its comparison to the probability will tell us if the probability is rare enough for the hypothesis test we're performing. Alright, so number 3 says to identify the significance level in our running example. Number 3. very last line of our running example says, at a 5% significance level, test the claim of the magazine. Oh, so the significance level, or alpha, will be 5%, or as a decimal, that's 0.05. Well, this also means that when we complete this hypothesis test, the total area in the two tails involved is also 0.05. Well, half of that would be in each tail, so 0.025 is the amount in each tail separately.